Welcome to aminacademy.com. In physics, regarding electric generators and motors, let us do some solving problem. Look at this example. An AC generator produces an output of E equal 180 sine 377t, where t is in seconds. What is the frequency of the AC voltage? Look at here, this equation, EMF equation is equal 180 sine 377 where t is there in seconds. What is the frequency of the AC voltage? Here, a sine curve plotted as a function of time is no different from cosine curve except for the location of t equals 0. When t equals 0, the location will change to the cos curve, that is equivalent to equal 2 pi n a bf cos 2 pi ft. So here we have to equate 377t is equivalent to 2 pi ft. Both t cut, then frequency 377 by 2 pi. While it calculate, it becomes 60.03. Hence, we can equate this one as 60 approximate 60 hertz. Next question. When turning at 1800 rpm, a certain generator produces 100 volts. What must be its angular speed if it is produced 120 volts? Here, two form of generator. When turning 1800 rpm, certain generator produces 100 volt. When it is what is its angular speed when the voltage is 120? Here, before first form it is 100 volt, second is 120 volt. Look at here for this. Here, because the amplitude of the EMF is proportional to its angular speed, if we have two speeds F1 and F2. Look at here, EMF 1, the second situation EMF 2 equal F1 by F2, which gives F2 equal F1 into E2 E1, then which is equal here 1800, then into E2 is 120 divided by 100, which is equal 1800 into 1.2. 1800 into 1.2 equal 2160. 2160, that is frequency F2. That is the second frequency is 2160 hertz. Next one. Next question, look at here. A certain generator has armature resistance 0.096 ohms and develops an induced EMF of 140 volts. When driven at its rated speed, what is the terminal voltage when 60 amp is being drawn from it? That is, here the generator acts like a battery with EMF of 140 volt here, and internal resistance R equal 0.096 ohms. Then, as with a battery life, terminal PD, terminal voltage now, terminal potential difference equal EMF minus here 140, EMF is 140 minus 60 amps IR, that is I is 60, internal resistance is 0.096, which is equal, EMF is 140 minus 60 into 0.096, which gives 134.24 volt. That is PD, terminal potential difference is this one, because here EMF is 140, then IR, I means current, R is small r is resistance, so that is subtracted. Next question, a certain shunt generator has an armature resistance 0.060 ohms and has a shunt resistance of 100 ohm. What power is developed in the armature when it delivers 40 kilowatt at 250 volts to an external circuit? Also find its generator efficiency. Here, look at here, this current to external circuit, here first, current external circuit is, suppose Ix, is powered by volt, P over V by Ohm's law, then which is equal 40 kilowatt is 40,000 watts divided by 250 volt, which is equal 160 amps. Current external circuit. Field current, because it is internal resistance it have. Field current is IF, which is equal VF over RF resistance. VF is 250, RF is that the shunt current is 100 volts, which is equal to 2.5 amps. Armature current, IA, armature current IA is IX plus IF, which is equal IX is 160 plus 2.5, which is equal 162.5 amps. Now we'll find Power loss in armature. Power loss in armature is, we know that formula, I squared, Ia squared, armature current, resistance armature, which is equal 162.5 the square into RA. RA is 0.06 ohm. 0.06 ohm, which is equal 1600 watts, which is equal 1.6 kilowatt. Then power loss in field, that is field current, that is If square into resistance of field, which is equal, If is 2.5 square. Here 2.5 amps, that square, into RF. RF is 100 ohm, which is equal that is 2.5 square, equal to 2.5 into 2.5 into 100. 625 watts, which is equal 0.625 kilowatt. That is power developed. Power developed is total power developed is 40 kilowatts, and power loss is 2 power 1.6 plus 0.06, 1.6 plus 0.625. This total power loss, which is equal 42 point. Here we'll add up this one, 40 plus 1.6 plus 0.625, 42.225, 225, which is equal 20 kilowatts. Also, we have to find efficiency of the generator. Efficiency power output by power input, 42.225 into 100, which is equal 40 divided by 42.225 into 100 equal 94.73%. 94.73% efficiency. Next question. The resistance of the armature in the motor is 2.5 ohms. It's a motor. It draws a current of 1.8 amps when operating on 120 volts. What is its back EMF? Next is as here operating with 120 amps, which is equal. The motor acts like a back EMF in series with IR drops, that is amps and resistance product, through its internal resistance. Therefore, line voltage equal to back EMF plus IR. Therefore, back EMF equal to line voltage. Line voltage is 120 minus IR. I is 1.8 into 2.4 equal 115.68 volts. That means back EMF is this much, because line voltage is to the given motor. Line voltage given to the motor is 120 volts, but back EMF have 105.68 volts. Next question. A motor has a back EMF of 110 volts and has an armature current is 100 amps when running at 1800 RPM. Determine the power and torque developed within the armature. Then we know that power equal torque equal to armature current in back EMF power is armature current into back EMF. Here, therefore, which is equal, power is equal, armature voltage is 100 amps into 110 volts. Which is equal watts, equal to 11 kilowatts. Now torque equal power by angular speed, which means P equal to T omega, angular speed. Here torque power is 11,000 watts. Angular speed you have to calculate. RPM is 1800, therefore RPS, revolution per second, is by 60, 30 radian per second. That is angular speed is 2 pi into RPS is 30, which equal 58.38. 38 Newton meter, so approximately 58.4 Newton meter. So far we discussed about some solving problem regarding electrical generator and motor. We have done. Please subscribe our YouTube channel.